So now we're just going to do a little bit of practice for now. So give this a shot. Try, if you're ready, try to pause the video and try this and say, make sure you understand the notation and try to do the problem. Okay, now if you aren't ready, if you either pause the video, great. If you didn't pause the video, here we go. Now this notation means do the derivative where z is your output variable and we're going to treat x as our input variable. So x is our variable, which means every other variable you see is a constant. So y is a constant. So here we go. When I'm doing this problem, derivative of z, so it's dz dx equals. Now, x is my variable. Does this first term have any variables? No, it does not. So that means this whole term becomes 0. Plus. All right, now here comes some old derivative rules. What derivative rule do we see here? Well, if you remember, we've got an inner function and outer function. That's a chain rule. So how I teach it is I say ignore, first of all, identify, is there a variable? Yes, there's an x. So therefore, what we're going to do is say, all right, work from the outside in. The derivative of something cubed is 3 raised to the something squared. And what do you do with the stuff on the inside? I always call it leave the junk alone. Then we scratch out and say we did the derivative of the cubed. Now we do the derivative of the inside. What is the inside? What is the stuff we have not done the derivative of yet? Well, that is 2x minus 4. What is the derivative of 2x minus 4? 2. And that's a pretty standard, this looks pretty standard to your old calculus stuff, not even in the 3D like we're doing now. So there you go. And you could simplify this a little bit. dz, I keep using the wrong d. dx is equal to, we could take this 2, multiply it there, so that's going to give us 6 times 2x minus 4 quantity squared. And there's no reason to have to multiply that out. All the online math grading systems will accept it, multiplied through, distributed through, or factored like this. It'll take all the answers, whether it be WebAssign or MathAS or whatever your class is using. They all accept it. So don't feel overly pressured to distribute it through. It's more about getting the right answer. Okay? So now, what does this notation mean? All right, again, pause the video, give it a shot. Okay, now, here we go. This is saying the derivative, again, output variable z, input variable is y, which means x is a constant. So therefore, all right, first term, y, does that have a variable? Yeah, it does. It has y to the first. So therefore, what's the derivative of y to the first? Well, that's 1, y to the 0, which we all know that makes 1, so the answer is just 1. Plus, now what's the derivative of 2x minus 4 to the third? Well, ask yourself, is there a variable there? No, because y is our variable and there's no y's. So this whole thing is just being multiplied by y to the 0, which makes the whole thing become 0. So therefore, the derivative of z with respect to y, the partial derivative of z with respect to y, is 1. And there's your answer. Okay, so hopefully that was helpful. Now, on to what makes everybody super duper happy, word problems. All right, now I just purposely chose simple interest. Interest equals P RT is what you may be used to. The way that this is written is dividing by 100, so that that way your interest rate is actually written as a percentage. So if I wanted to put in 7%, I would just literally put in 7. But think about it, 7 divided by 100 is 0.07. Okay, so that's all this dividing by 100 is doing, is it's just making your percentage written as a fraction, or you actually fill in the value opposed to having to shift decimals and do that stuff. It really doesn't matter. Your mathematics skill level, you should be fine with it either way. Now, what the formula is saying, this is not compound interest. This is simple interest. So literally, it's just telling you how much interest you earned when you put in some amount of principal at some interest rate for some amount of time. And note, the units should all match. So your time should be measured in months or years or whatever. Your rate should be measured in that same length of time. So generally speaking, they're usually measured in years. So number of years you have it in the account, and the interest rate is percent per year. Okay. But we don't try and trick you too much on that, but every once in a while it causes an issue. So here we go. So there's our formula. And we're going to say a client came to you saying they have $1,000 to put in a bank account. They have 3 years to leave it in the bank. And right now they are being offered 4% interest rate. Okay, so what we're going to say is by changing the interest rate but holding everything else constant. So what that means in the real world, what we're saying is I can't give them more money to invest, and I can't change how long they have to invest it. If they want to retire in 3 years, they want to retire in 3 years, or they want to buy a car in 3 years. I can't change that. But the interest rate, maybe I can change. I can put them in a more aggressive investment, or maybe I offer better interest rates, or whatever. So what we're saying here is the thing we have the ability to change is the interest rate. Well, we learned way back when things change, that's called a variable. So what we're saying is R is a variable in this problem, but everything else, the time and the principal, are constants. They don't change. So this is a real world example of when we see a real problem, what is a constant, what is a variable. So now the question is saying is what is the increase in interest per percent increase? So do you hear what it's saying? Do you hear the derivative? Because remember, it's a d, wrong d, I did it again, d something, d something. What is changing? Output, input. So change in interest per percent, and our percent is measured in the variable r. So the words are specifically telling you I want the derivative of I with respect to r. And you can see I also gave you a little hint here. I put it in this notation, the I sub r. Okay, so let's figure that out. Let's do that derivative. Now, it can be a little hard sometimes because there's a lot going on in this equation. So sometimes it helps you rewrite it so your variable's on the right and all your constants are the left. This is just multiplication and division, so I can rearrange it any way I want. So I'm going to take all of my constants and put them on the left. P is a constant. The dividing by 100 is a constant. And the t is a constant, right? All of that stuff would just be multiplying my r. And if you're saying, whoa, 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 how did I do that? Just put everything over 1. And just remember how we multiply fractions is straight across. So this would be the equivalent of p times r times t all over 1 times 100 times 1. And so I can kind of rearrange it that way. Now when I look at it this way, all this stuff in the parentheses is a constant. Treat it like you would any number and say, all right, I'm ready to do, whoops, right, I haven't done my derivative yet though, so this is just my I. There we go. So now let's do di dr. My r is my variable. All this stuff, we're going to ignore it. We're just going to say, is it multiplying an r? Yes, it is. There it is. R to the first. So the derivative says, bring the 1 out to the front. So this is going to be 1 times t divided by 100 times r to the 0, and r to the 0 we know is 1, and I don't really need to write the 1 out in the front, so there's my derivative, right? Now, next I wanted to show you a little bit of notation. We are going to say, what was the value for this person? We know what P is, right? We know what their principal is. It was 1,000. We know what T was. T was 3 years. So what we're going to do is we're going to substitute those numbers in. And how we do that is I'm going to use, you could either, if you're using the other notation, it would just look like that. Or what we can do is use that same kind of notation here where we're going to write 1,000, 4, 3. So notice with the Leibniz notation, you just do the di over dr with a big bar next to it and the values you're substituting in. And now we put an equal sign. So, all right, our principal was 1,000. Our time was 3, and we're dividing by 100. So now the simplification, 100 divides with that, leaving me with 10. So therefore, this is just going to be $30. So now let's interpret. This is the key. I kind of said it already, but let's make sure we got the whole thing. Interpretation. Think about your units. This is treated like a fraction, and your numerator units will match the numerator. Your denominator units will match the denominator. So what are the units on interest? Well, that's dollars. What are the units on the rate? That's percent. So what is the answer to this? We had a I'm going to write it out. We had a $30 increase in interest per, because there's the division, 1% increase. Okay, but notice we're not done yet. Okay, but that's the big idea. The interest went up $30 per 1% increase in interest. So if instead of going from a 4% to a 5% interest rate, we'd go up 30 bucks. But we need to mention the other variables that got used in the equation. What values did I have to substitute in? These are key. And so I'm going to put a comma and put when. When what? When investing $1,000 for 3 years. Was it important for me to mention that the interest rate was 4%? Well, no, because in my derivative, looking back at this derivative equation, did it matter that the interest rate that the person came in was talking about was 4%? No, all that I used was the principal they're spending and the time that they're going to be, or the principal they're investing and the time that they are doing it for. Regardless of the interest rate, it didn't matter. If I can raise you up 1% from wherever you are, it's always going to be a $30 increase. Okay, there's a example problem. In the next video, we'll move on to another example.